Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, thank you very much for the introduction, and thank you very much to Microsoft to make possible this event and for inviting us to present our work. So I'm going to talk basically about a system that supports different tasks which are related to biomedical images. This work was developed by our research group, Bioingenium, from the National University of Colombia, and also the International Physics Center of Colombia and the Universidad Politécnico Gran Colombiano. Okay, so the general problem that we are dealing with here is the same problem that we heard about in all again and again in all the presentations. Is the data deluge, the big amount of data, and obviously the biomedical field is no exception, and actually is a very interesting area to apply all these different computational tools that can make sense of all this data has been collected by researchers, but also by the clinical practice itself. So we have complex objects that comprise visual and non-visual information, and that's very important, the diversity, the multimodality of the information. And this is a very important resource for diagnosis, research, and also obviously for training of researchers and medical doctors. Okay, so we specifically concentrate on the medical image collections. So there are many interesting things on the medical image collection. One important thing is that actually nowadays there are many different repositories actually in every hospital. You will find a system to deal with images, and images are collected every day. The problem is really not how to access a specific image or information on those repositories, but how to really make sense of all that collection, and that's the problem that we are trying to address here. So we have not only the images, the relationships between the images, we have also metadata like medical history, medical records, or we have also images could come from papers. Also we have ontologies, and also we have user interacting with the images and with all this data. So from a computational point of view, we have different problems that are related to the general problem of dealing with this big amount of data. Okay, so one thing that I want to clarify, that I am a computer scientist, and so my point of view on this problem is from the computational, from computer science, and but obviously we want to solve concrete problems, and here we have some particular examples of the type of research and medical practice that we are supporting. So one area is research. This is an important group in our university that basically works on cell biology, and they do different kind of studies for different methodologies to do cell cultures, 3D cultures and to study different types of tissues, to analyze function of different organs, etc., etc. Most of this research is related to medical conditions which are typical of our area. But the important thing here is that medical or images are really an important source of information for their work. So this is a typical paper from this group, and they really relied heavily on this kind of visual data. So what are the advantages of an image management system for these researchers? So one important thing is that the material that is the basis for this, which are basically slides that are analyzed under the microscope, can be, if you have in a digital representation, you can reuse it, but more than that, that has been done for a while now. But really the possibility of doing collaborative work, okay, so to interact with your partners and other labs, etc., the integration of the information, also the general, the support of the general workflow in the scientific process, the knowledge dissemination, and obviously teaching support. Okay, so this is a collection that we work on. Actually, we have a joint project with this group. And we got money to collect 20,000 histological images, and the main purpose of this data set was to have a representative data set of images of the four main tissues, and 9,000 of those 20,000 images were annotated. Okay, so that was done using our system I'm going to talk right now. Okay. And this is another example. This is the pathology lab at our university. This lab is, they do research, obviously, but also they support or offer services to support clinical diagnosis, so histopathology, cytopathology, immunopathology. And all of them, to some extent, all of them relies on the microscopical imaging. So again, there are many advantages of having this kind of systems to do evidence-based medicine, to make the diagnosis of a new case based on previous cases, collaborative and remote work, support to clinical studies and trials, and also, obviously, physician training. Okay, so this is a collection that most of the information they have is physical, the physical slides. So we acquired those images using, we converted or acquired digital images from those slides. And the purpose of this particular set of data was to analyze one particular disease that is called basal cell carcinoma. It's basically cancer, skin cancer, related to skin cancer. And in this case, the specialists, the pathologists that were involved annotated 1,500 of these images with particular information about the diagnosis of this kind of cancer. So for each image, it can exhibit any of the different 18 concepts of one or more of them. Okay. So also we support a telemedicine project. It is important to take into account that we do this research in a developing country where health is a big issue there. Okay, it seems that it's a big issue everywhere, but There, one of the problems is that there are underserved regions where it's difficult to really have access to specialized medicine. So we also, this is very relevant for our country. The idea of this is to support in the future a telepathology system. So this is also one of our motivations. So what are the requirements of the system that we built? So we want to make image management, addition, deletion, updating, image annotation, global annotation, annotations of the regions. The user must be able to search using text keywords, but also query by example. Here, this is very important because the idea is that in some cases you don't even know how to describe what you are looking for, but you have an image and you want to look for those images which are similar to that one, and also to make the user able to explore the collection. So this is the global architecture of our system. I think I have a pointer here. Here it is. Okay. So it is a system. The architecture of the system is wow. The architecture of the system is based on services. It's a service-oriented architecture. And this is the front end that the user have. It's a web application. Everything is accessed through the web. And there are different services. The main service is the storage service. So we have a system that encapsulates a database that all these can be distributed. The system is modular. And we have metadata services, annotation services, and also we have additional services to access efficiently to the data. So we can do indexing by text, indexing by the visual information of the images. And these indexing services support the retrieval services where the user actually can't get the information that he's looking for. Since this is a service-oriented architecture, the system can be accessed by other applications to use the services. So there are other developments in our group, like 3D reconstruction, if we had, for instance, MRI images or systems for doing automatic annotation, etc. Okay, so I'll go to show the system working. I hope the internet connection is right. The resolution is not the ideal resolution for the system, but this is the main page of the application. Okay, so it's a web-based application. By the way, this is a new functionality. A good thing of a web application is that the system can be updated continuously, and so my students are doing a good work. So you can look for the specific type of information using the text search, and this is straightforward. Some of the images have annotations, some of them not. For instance, this image, okay, so some of them have a global annotation, this doesn't. And some of them have region annotations, like this one. Okay, so an image can have more than one of these annotations. Okay, let's better. Sorry. Okay, so wow. Okay, yeah, there it goes. Okay, so also, this is the interesting part. Okay, so here we have annotations, and we can look for similar images to the one that we are checking at a given moment. So it's actually looking for images which are similar in content to the given image. It could be based on color or edges or texture, and this is a handy tool when you really don't have, for instance, in this case, most of the images are not annotated, so you need to access to the information. You need this kind of tools, okay? Also, you can't, for these images, you can edit inline. Okay. And do image processing tasks, such as, for instance, find edges or things like that, that in some cases are useful to make information explicit, okay? Also, we can do things like this. We can show, okay, let's look for similar images to this one, and then we can organize the results of the search in the 2D visualization that makes easier to explore and to look for information, mainly for visual information. This is really a better way to look a good number of images at the same time. So right now, this application, the purpose of this project was actually to build this repository of images. This is called a histological atlas, and this is accessed by different people in Colombia. And mainly now, the main purpose of this is support teaching and of people in biological sciences, medical sciences. However, for us, this is an important tool to test different ideas. And so I want to talk, okay, this is the supporting technology of the, it's basically Java-based, but we integrate other technologies for the text indexing, for the image edition, et cetera, okay? Okay. So these are the type of things that we are working on, and we already integrated on the test systems, not in the production system. So one is to do semantic content-based image retrieval. So in general, for this application, for all the interesting applications, when you look for images which are similar, actually what you are looking for is not similar from a low-level point of view, but similar from a semantic point of view. So this is very important. It's very important. So here we use machine learning to annotate automatically. We have label images and annotated images. We use those to train machine learning algorithms and to have a semantic representation of the images, so we can retrieve images using this semantic content. So this is just an evaluation. This was done in the carcinoma vasocellular carcinoma that the data set that we talked at the beginning. And this is the performance of, this is a precision recall graph common in information retrieval. So what you really want is to have the higher precision and the higher recall. So usually these graphs behaves like this. When you get more information, then the precision goes down. But if you are using only low-level visual representation, the precision goes down very fast. We use semantic representation. We did. You can keep a very good precision with a high recall. Okay. Also. The visualization, the exploration of the database is an important issue. So we address it using summarization, visualization tools. Basically what we do here is to apply the dimensionality reduction techniques and then clustering non-supervised machine learning algorithms to extract good samples from the representative samples from the database, and that's what we show to the user. So, but there are really many problems that had to be solved. For instance, the image clutter here, so some images are overlapping other images. So, but those are problems that has been already addressed in general. But our goal here is how to use those tools to make a tool that is really useful for the users. Also, interactive machine learning. This is a very interesting problem. Also, how to allow the user to train his own models for doing classification. Also, for the telemedicine, if we want really to have something like telepathology, we want to send high resolution, very high resolution images to the pathologists through a network that in our countries are not really fast. So we look for ways to represent the information in an efficient way, to send only the information that is important. So this is the virtual microscope. And also, we want to provide tools that allow to analyze the patterns that you can find in the images. Okay, so this is a very broad view of our work. We have this web-based application already for biomedical image management already in production, and it has, when compared to other similar tools that you can find for the same functionality, but it has an enhanced functionality for search and exploration. And, but the important thing for us is that actually it provides a good test bed to try different new algorithms that we are researching for the image analysis, image understanding, for image retrieval. Actually, this system has been useful for the users on the basic functionality. Obviously, it's better to have this kind of information in a digital form that you can access from everywhere than having used the physical slides. But the big question is all this fancy interface and all this functionality. What's the real impact of this type of technologies on the research and clinical tasks that the users have to accomplish? So this is a next step on our research to test exactly which of these exploration content-based retrieval functionalities was the impact, the actual impact of these technologies. Okay, I have to acknowledge the members of our research group, the Advanced Technology Academic National Network that funded the work, as well as the Department of Education, and some of the developers that were involved in this work. The system can be accessed at this address, and if you want additional information, you feel free to contact me. Thank you very much.
Fabio, have a couple of minutes. Yes, at the back, please.
Have you looked at regional experience? You compare whole images, but probably if you have some shade on your image, it won't be always centered or always in the top left, but you will be rather interested in what is.
Yeah. Yeah. Actually, there are different ways to calculate the similarity between images, and yeah, we have some metrics that are sensitive to position, others that are not sensitive. But in general, the problem is how to have a good similarity measure that makes sense for the user. So when I see these images, I can say, okay, this image is similar to this one because, for instance, they have the same color, or because they have similar shapes. But if I show it to a pathologist, for sure, the notion of similarity of a pathologist for this kind of images is different to mine. So really the problem is how to take different similarity functions that, in fact, we are doing that, and align that with the notion of similarity of the pathology. Yeah, we have tried different low level, but in general, no one of those will work as expected if you don't involve semantic knowledge.
Another question from the floor? Yes. Please.
In your image database, do you have a sort of quite extensive schema to put in metadata about the pictures, or is it free-form?
It's freeform. It's freeform. Yeah, it's freeform. Basically, what we stored is an XML. Yeah. Yeah, I mean, we can use an ontology, but it depends. In our architecture, the module that takes care of the storage of the images only knows that each image has an XML associated. But the interpretation of that information, if you have a particular application, when you need some particular structure for the metadata, that application, another web service or another application running on another computer has to parse that XML and yeah, give sense to that XML. Yeah.
Just to clarify, I had a similar question that if there's an XML file, that's the metadata, the link essentially got pointed to an XML file.
Yeah.
I think there could be some interesting further work there. Okay, if there are no more questions, we'll go to our next speaker. Thank you once again, Fabio.
Okay, thank you very much.